my name is Lundgren, and I'm here to talk about a technique where we measure electromagnetic near fields using a metasurface together with an infrared camera. In our paper, we demonstrated for 28 GHz, but of course, the concept is more general. So why is it useful? Well, consider an antenna array, such as image here. Performance in near field could, of course, be of interest on its own, but also if you have, for instance, defects of some kind, this could affect the entire performance of the structure in unknown ways prior to measuring it. So antenna behavior in the near field could be important for this reason, and we wanted to develop a technique which can rapidly carry out measurements and can do that very simple. And our solution here lies in using a metasurface. So we created a screen printed structure with small elements that could be placed in front of our device under test. And in this paper, we have many U-shaped elements, and they convert the incident energy into heat and concentrate that locally. So each element here acts like a pixel in an ordinary camera, and they become warmer in proportion to that incident energy. So by transmitting a pulsed signal, we can observe this metasurface with an infrared camera and capture a temperature map of what we're looking at of our device under test. And since each element here corresponds to one measurement point, we can get a thermal image. Here we see one from what the camera sees. You can see that the elements are blinking on and off, and this heat here directly corresponds to the electromagnetic field at the surface. So we can post-process this data and create some kind of heat map showing basically how each element responded when placed in front of an antenna array. We demonstrate this in the paper for two cases. First, it's for fault detection in antenna arrays. Here we have an experiment with 168 radiating elements, or possibly radiating. And we can see that not every element behind this metasurface was actually radiating. We can see that only some were turned off, forming some kind of smiley face here, but also with different amplitudes between them, all imaged in a matter of seconds. Second, we also did near-field mapping, and here we could move the metasurface or the device under test to combine multiple measurements. Here we illustrated with an open-ended waveguide probe that we measured on. But of course, we also took this measurement into a mock-up. We measured a phone mock-up at 28 GHz. We measured two different planes of this phone, and we could resolve fine details, measuring peak power density levels of 6 milliwatts per centimeter square. So in summary, this is a technique that provides rapid, large area visualization of the millimeter waves in near field, using only metasurface and an infrared camera. For more details, please read the paper or just contact us directly.